Today's mini lesson is on product of powers. We're going to start off with a little bit of a review. The review section here, we have 3 to the power of 0. We know anything that has an exponent of 0 is 1. 3 to the negative third power. Today what you'll need to do in your assignment is you cannot write anything with a negative exponent. Therefore we need to get rid of a negative exponent. In order to do this, if your problem is not a fraction already, we need to convert to a fraction right away. Once you convert it to a fraction, it's easy to get rid of your negative exponent. In order to get rid of your negative exponent, you need to move it. So if your negative exponent is on the top, we'd move down to the denominator. When we do that, we now wind up with 3 to the third. Notice that the negative exponent is taken care of, and we'll go ahead and put a 1 on top here. Today it will also ask you to simplify your problem. So in order to simplify, 3 to the third is 27, so we wind up with 1/27. Extra note here, just note that any time that an exponent is not present, you can give any number or variable an exponent, and that exponent is 1. So if you look at the example here, we have 2. 2 is really saying 2 to the first power. So when you come across a problem today, go ahead and give 2 that exponent. Or if you see the variable, go ahead and give that variable an exponent. Okay, because if you had 2 and you're like, oh, there's no exponent, and you put a 0 there, 2 to the power of 0 is 1. Okay, these are equal. 2 equals 2 to the first because we put the exponent of 1 there. Example, product of powers. It gives you a quick little rundown here, but in order to multiply powers, it has to have the same base. That's big. Same base. When you have the same base, you go ahead and add the exponents when you multiply. Quick example here. We have 2 to the third times 2 to the fourth. 2 and 2 is our base number. 2 to the third is written as that. 2 to the fourth is written like that. Now if you go ahead and multiply all those 2's together, basically what that is saying is 2 to the 7th power. Quick way to write this down for your assignment would be here. Okay, have the same base. Here's your base number 2. It is multiplying, so we go ahead and add our exponents, the 3 and the 4. When you add your exponents, you get 2 to the 7th power. Simplified, we get 128. Looking at our first example, the rules say simplify. Answers should contain only positive exponents. So when we go ahead and simplify here, we notice that we have 5 to the fourth times 5 to the negative first. 5 is our base number. Multiplying is happening. When you multiply and have the same base, you add your exponents. So 4 plus negative 1. We wind up with 5 to the third power, and simplified that as 125. Example 2. Again, base number, all the same, 4. Multiplying all those same base numbers. So we can go ahead and add our exponents, and you really wouldn't have to add the 0 here. It's not wrong if you do. Add that together, we get 4 to the negative second. Could not leave our answer like this because it is a negative exponent. We need to go ahead and do our conversion here. In order to do that, to get rid of negative exponent, we make this a fraction. Once we make it a fraction, we move what the negative exponent is, and the negative exponent is right here, 4 to the negative second. Move that to the bottom, we wind up with 4 to the second over 1. Still wouldn't be completed because we can simplify this a little bit further, and we get 1 over 4 to the second is 16. Example 3, negative x to the third times negative 5x to the negative third times negative 4x to the negative fourth. Looking at our problem here, you would notice that not everything has the same base. The ones that have the same base are the x's. The x's have the same base. Those are the exponents that you could add together. So we have x to the third, we have x to the negative third, and x to the negative fourth. Those are our same bases. Notice that the numbers or the coefficients out in front of the variables are not the same. In this case right here, you can put a 1 out there, so this is really negative 1 times negative 5 times negative 4. Different ones, different terms there, so we're going to go ahead and multiply those out. The ones that have the same base are x's, so we had x to the third plus negative third plus negative 4. There's our same bases, so we can add those exponents together. Here we get negative 1 times negative 5 is 5. 5 times negative 4 is negative 20. And we say x, well, 3 plus negative 3 is 0. 0 plus negative 4 is negative 4. Again, couldn't leave our answer like this because of the negative exponent, so we need to go ahead and make this a fraction. The term that has the negative exponent is x minus 4. 20, negative 20 I should say, really does have an exponent. It has that exponent of 1. So x to the negative fourth needs to move to the bottom. Our answer, negative 20, stays on the top. When we move it to the bottom, it gets rid of the negative exponents. We wind up with negative 20 x to the fourth. Example 4, same scenario as example 3. I'm going to go ahead and throw a 1 in front of n to the fourth. I look at this, my same bases are the n's, so that's where I can, when multiplied, I can go ahead and add the exponents. So my coefficients is 1 and negative 5. I'm going to go ahead and multiply those together. Same base, I have n. When you have the same base and multiply, you add the exponents. So 4 plus 3 there for n. Multiply it out, we get negative 5n to the 7th power. And we don't have any negative exponents, therefore negative 5 n to the 7th is our answer. Example 5, I want you to go ahead and work through. One comment that I would make here in example 5 when looking at this problem that normally I see a lot of problems here is r really has an exponent that has an exponent of 1. So go ahead and put that on your paper anytime you see that exponent is missing. Go ahead, pause the video, work through it, and we'll join back up. Now that we're back, we have negative 3 and negative 4. Different bases, so we're going to go ahead and just multiply those numbers out. We have our r, well we have r to the fourth times r to the first, same base, add exponents. We wind up with 12r to the fifth. Example 6, again, pause it. Well, actually, we'll go ahead and work through it here. Reason being is I wanted to point something out here. We have negative 4 and negative 4, again being multiplied together. That is the same base. Negative 4 really has exponents of 1. So I can say negative 4, same base, add exponents, so 1 plus 1. X's also have the same base, and they are being multiplied, so I can add their exponents. When I work through this, I get negative 4 to the 2nd power, and I have x to the 6th power. Negative 4 to the 2nd power is negative 4 times negative 4, giving us 16, x to the 6th. This concludes our lesson on product of powers.